In this tutorial, I'm going to show you how to subset Pandas data frames. Now, let me say that the Python codes I'm going to use, everything has been packaged into this Jupyter notebook here. So if you want the notebook, then check the description box. You'll find the link to this notebook. Now, I will switch to the empty notebook here because I'm going to do an interactive session. Now, for this tutorial, I need to make sure that you have Python installed in your system, and you should also have Pandas installed. If you don't have Python installed, or if you don't have Pandas installed, don't worry, you can still follow this tutorial, all right, for the most part. So all I have to do is to visit the Google Colab platform using your browser. So there's the platform, and I'll leave the link to this platform in the description. So when you are here, click on New Notebook, and then a new notebook will be open for you. If let's say you have clicked outside this window, then you will see something like this, and you can still come to this side, File, and then click on New Notebook. So this will open a new notebook for you, and then you can start writing your Python codes. So you will see something like this, and you can start typing. So you can just test, let's say print hello world. Let me just write it here. Yeah. Then you can click on this to run. There are also keyboard shortcuts that you can use. So if you open the new notebook, obviously it's going to be the first time you will use that very notebook. So if you execute the first code, it will take some time and it will be executed. And then from there, all the codes will be run faster, to be run quickly for you. That's what I'll see. So if you are running it for the first time and there's a delay, don't worry. Once everything has been initialized, you will see something like this, and then the codes will be executed for you quickly. All right. Now let's visit the other notebook, which is here. Okay. So let's do this. We are going to use Pandas, and we're also going to use an example data, which I'll show you very soon. All right. So let's first import Pandas. So I'll do that here. So I'm going to say import Pandas as PD. Then I'll execute it. All right. Now with the execution, you will notice that I did not use my mouse to come and click on run. I use the keyboard shortcut, which is Alt and then Enter. But you can also use your mouse to click on run. That's also fine. All right. So take note of that. Okay. Now we need to read the input file, or let's say the example data. All right. So I have already prepared the data, so you can find it on this GitHub repo of mine. All right. So there's the repo. I'll leave the link to this page in the description box. So now here you find lots of files. We are going to use this one, dsig_results.tsv. This is what we are going to use. You see there are two files with the names dsig. Okay, starting their respective names. All right, we are using this one, dsig_results.tsv. So make sure you select this one here. So to download, you click on it, and when you click on it, you'll see something like this, and then you can click on raw. Okay, so when you click on raw like this, you'll see something like this, and you can right click and then go to save pages to save it. Alternatively, you can come here and then click on this, and then this will download it for you. So click this one, the download icon here, this will also download for you. So any of them should be fine. All right, so make sure to download it. Okay, so I have mine already downloaded. Let me just show you. It's here. So this is mine, by the way. All right, so you can download it and read it. Alternatively, you can just load it straight from GitHub. That's what we are going to do, by the way. So you don't need to even download. You can just load it straight by getting the download link. All right, so I'll show you that. So to do that, just come to raw, right click, and then go to copy link. All right, this will copy the link for you, and then you can come back to Pandas and then read it. So to read it, I'll do this. I'll first define, I'll say file, or let's say data file. Any name is fine. Just try any variable name. All right, so any of them is fine. Okay. Then I'll say equals, and I'll put the link in two double quote because we are dealing with a string data type like this. And I'm going to run it. All right, so when I run it, if I do a print statement, I should see the link. And then once I see it, that means everything is fine. And then I'll load it. So I'll just say df equals, I'll say pd.read csv. I'll bring my parentheses and I'll say data file like this. Now this file is a CSV file. You can see from the extension .csv. So that means that it's a tab separated file. So for the separator, you need to use a tab. So I'll say comma and I'll say sep equals /t like this. And I'm going to execute it. So this will read the file for me. Of course, if you are loading from GitHub, then it will take some time and then it will be loaded. But if you already have the file on your system, like in my case, just want to, then you can just load it straight. Also, you can just do it. Let me just do it here. You can just say df equals, then you supply it. All right. So you can also define this. You can say data file equals, and if you know the path, you can say /home/Kobana/ Pandas tutorials. That's where the file can be found /basic results.tsv. All right. So there's a file. And then I can just load it like I did here. I'll just do a copy and paste because it's basically the same command. And I'll execute it. So this will also load it for me. So any of them should load the file for you. So just try whichever one you want. That's fine. Okay. So we have loaded it. So everything is fine. I'll just proceed. I'll just clear this and then proceed. Okay. Now, before we proceed, let me just open this file here. I think we need to do some discussion here first. Just a brief discussion or description of the file. That's what I'll call it, especially for beginners, because I need to explain a lot of things, a couple of things for beginners to also understand. So this file here, let me just open it. I'll open it with my spreadsheet software. So this is a differential expression analysis results. This was generated using the SIG2. So basically it's an RNA-seq analysis results file. All right. So I have gen, I have p-ISF value, p-value, and some other statistics. Okay, statistics measurement here. All right. So we have some gens here. Okay, some of them are differentially expressed, others are not, but there's the results. So we are going to do some subsets. All right, we are going to make some queries to try to get some information out of it. It's also part of data analysis. If you have a table with lots of entries, obviously one of the things that you do is to do a subset or make queries or try to find some interesting information. That is what we are basically doing here. And so that means that if you have a data set, it's important that you have an idea of the domain, okay, from which the data set was generated. Or let me just say, you should first get a description of data, know what it's about, and then that will help you to know what to look out for. This is a differential expression analysis result. And so obviously we know that we can look for gens that are differential expressed. We can look for gens with values less or greater than certain threshold. For example, log 2-fold change. We can also look at gens with p-ISF values less or equals to or greater than certain value. So basically, I'm using this to explain how we can perform some of these analysis or some of these activities using Python. All right, so that's what we are doing here. Of course, with this expression analysis, you use R a lot, but if you have a table like this, then you can also use Python to do some analysis or look for some information. So that's what we are doing here. Okay, so I'll go back to Python. I've talked a lot. It's time for us to take action. Okay, so let's do this. Okay, so we have read our table. So if you have read your table, you can just do df just to see some of the entries here. All right, you can see some of them here. So if you do df, you see this 18314 rows by 7 columns. Right, so that's what you see. But you can also use another command to check the number of rows and columns. So you can just say df.shape. That will also give you the number of rows and columns. So here rows represents gens. So for each gen, all right, so you have the gen name, PSF value, p value, and all these values. That's what you see here. All right, so let's proceed. You should also take note of what you have here. You have 0, 1, 2, 3, 4, 5 up to this number here. So these are indexes. In R, you say row names, but in Python, it's index or indexes. So take note of that. So because we do not specify any column, numbers are used to label the rows. Or let's say numbers are used as indexes. So take note of that. So let me repeat. Index and the row names are the same here. They refer to the same thing here. So in R, you usually hear row names. In Python is going to be index. So take note of that. All right, so let's proceed. Now, if you have your table, you can also check columns. Because we are going to do subsets, we need to check the indexes and the columns, or let's say column names. So you can check that. So for columns, you can just say df dot columns, and you have the column names indicated for you. So these are the column names. So we have 7 of them. You can also manually count, and you see that it's 7. Okay. So we are subsetting. So with a subsetting, we are going to subset rows and also columns, but we are starting with columns first. So that's why we have to display the column names. We will later look at rows. So let's proceed. So we are going to subset columns. So for column, this is what we are going to do. We are going to subset a single column, but we will select all rows. That's what we are going to do here. Then I'm going to show you 4 approaches, and these approaches, you can also use them in other scenarios. All right, so it's important to get to know these different approaches and use the one which is convenient for you. So we will start with approach 1. So I'll start with approach 1. So approach 1, you just call your data frame, which is df, and then you bring your square brackets, and then in it, you specify the column that you want. Let's use gen name. So gen name, this is strange, so you put this in quotes and you can say gen name. So you can execute it and you're going to see something like this coming up. Okay, so you have something like this. Now with what you have here, this result here is a Python series object. So you still have your indexes and you have your values. But if you want just the values, that is the names themselves, and it's df gen name, and you add dot values to it. So this will give you just the gen names, excluding the indexes. So this one is an array, it's a numpy array. You can also convert it to a list. You can use it to make other queries. So at this point, you know what you want, you know what you are looking for. So when you get it, then you can proceed with whatever you want to do next. All right, now let's look at this. You can also assign this result to a variable. So you can assign it, you can just say hits, or for now it's not even hits, you can just say gen names equals, and then you paste your command, you run it, you can say gen names, and you have them here. If let's say you want the first 5, you can say gen names, like this, and you have them there, right? So these are things you can also do. Okay, so this is just an intro, so we'll proceed to the next approach. All right, so let's look at approach 2 for the same subsetting of a single column by selecting all rows. So approach 2, we'll just call data frame and you see dots and we specify the column. Okay, so you know you have different columns, so df dots, and then you can specify any of these. Okay, so that's what we are doing. So it's gen name, so we'll say gen name, and you have it there. Right. Again here you can say df.gen name dot values. That also works. Okay, so once you have it, then you can do whatever you want. Okay, so we are going to proceed. So now we are going to look at approach 3. That's what we are going to do here. All right, so I am going to do it here. So approach 3, we have it something like this. Then we proceed. So for approach 3, this is what we'll do. For approach 3, you use your df and you say .log. That's be the log function. That's what we use. That's for approach 3. Now you specify your square brackets, and then you specify the rows and columns of interest. Now for this approach, you need to specify rows and columns. And rows and columns are separated using a comma. And because we are selecting all rows, we bring a column, and then for the column section, we will specify the column of interest. All right. So the column of interest is gen name, and you can execute this command. So this will give you what you want. You can also use .values, and you get it like this. You can also try with a different column. Let's say PADJ. If you want, you can try and then let's see. Yeah, I'll just do it here. I can say df.log PADJ. I also have it here. So any of them is fine. Of course, you can add your .values also to get just the values. So that's one. It depends on you. Now let's move on to approach 4. So let's look at approach 4. Approach 4, we use the iLook. So iLook, that means we are using the lock, but this time we are using numbers rather, indexes, numbers. So with the iLock, we use numbers. So that means that you need to know the index of your columns. All right. Now let's do this. Let me do something here first. Let's display the columns again. So df.columns. We'll come back to the iLock later. So I have this. Okay. Now let's do this. Let's go to approach 4. Approach 4 is df.iLock. And then you bring your square brackets. The same thing, you separate rows and columns with a comma. But here we are using all rows. So again, we bring our column. Now for columns, here instead of the names itself, we use the indexes. So if you take a look at gen name for the columns, gen name, the index is 0. All right. If you do this, so let's say df.columns, you say 0. What comes with gen name? So the index is 0. So because we are using iLock, instead of gen name, we will say 0. Then we'll execute it. So that will give us an answer, or it will give us a result. But with iLock, let's just try it. If you say df, let me do it here, but iLock, and you say gen name, let's see what comes up. You get something like this. All right, it says you have this exception coming up. All right, so it says can only index by location. Okay, we are using the indexes. So here the name itself will not work, but rather we need to use the location or indexes. So here is 0. So if it's PISF value, then it's 1, 2, 3, 4 up to that. All right. For those who are beginners in Python, counting start from 0. In R, we would have said 1, but in Python it's 0. So take note of that. Okay. Now we can proceed. I will just proceed. Let me just say iLock works Unless ilog does not work with the actual column names. All right, so take note of that. I will just move on. Okay, so these are the approaches for getting the records for a particular column. All right, now you can also subset multiple columns and then select all rows. That's also possible. All right, for that one too, we can still do it. So we will try. Okay, and for that one too, you can still do with the approaches I made mention of. All right, so you can do it. So let's start with the approach one. So approach one, df, and you bring it here like this, your square bracket. But because we are dealing with two or more columns, then we have to bring them again in another list like this. Okay, so you have this, you have your first square bracket, and then another square bracket again for list, and then you specify your gen names. Not gen names, you specify the columns, but gen name is one of the columns. All right, so let's just type the columns here first. ef.columns. So let's use gen name and p as a value. So you bring your gen name, comma, padj, comma, like this. And then you can execute the command. So this will give you the results. All right. If you want just the values, well, the same thing goes. And just say the values. And you get them here. So here you have this and this. Right. You can also assign the operation to a variable and then save it as well. That's also something you can also do. So that one, I'll leave that up to you. But you can also watch my introductory video on Pandas that shows how to also save subsets. All right, so if you are new into Pandas, then I will highly encourage you to check my introductory video on Pandas. That gives an overview of the Pandas environment. So the link to that video is in the description box. Okay, so let's try with approach 2. So you have df. Let me just do it here. So we have df.lock as for approach 2. And then you bring your colon, comma, and you specify this list again. And then in it, you say gen name padj like this. So this is for approach 2. And that will give you your answer. All right, so we have that here. Approach 3, df.ilog colon 0, 1. Because we have 0 and 1. The gen names, not gen names, columns. The columns, you have gen name and padj. All right, so gen name is one of them, by the way. We have gen name and a padj. So 0, 1. So that's what we are given here. So we can execute it to get the results also. So it's very, very simple and then straightforward. Now let's proceed. So these are approaches you can use to also select multiple columns and all rows. All right. Okay. Now let's proceed to subset rows. So before we do that, let's first check the row name. So to check the row names, or let's say index, okay, check index into brackets row names. In Python, we refer to row names as index. Okay, so we have that here. And then let's correct this. This is row names. So row space and the names. All right. So to check the index, you say df.index. It's just simple and straightforward. You execute it, then you have this, right? Now let me do this. We see this range index. Let's say df. Let's call this, right? 0 up to this. All right. So here, instead of showing all the numbers, or even in this format, it just tells you there's a range. So that means it starts from 0 and then it moves to 18314, because these are numbers. When we read the file, the indexes were given as numbers. Okay, so Python generated its own indexes for us, and that is what we have. So the indexes, they are numbered, so every row gets a number. So it's in an increment of 1. So we start from 0, 1, 2, 3 up to this. The step in. So that is why we have it this way. But if you want to see the numbers themselves, then you can just say list bf.index. That will give you the numbers themselves like this. Okay, so that's something you can also do. For this one, we have a tall list because we have over 18,000 records. So you really want to think through and just make sure that this information is really needed or it's really necessary. All right, so that one, it's up to you. So sometimes too, there's some information that you don't really need to display it, but you can use it later on for processing without you having to display. So here, there's a very tall list, so you can see what is happening here. Okay, so what I'm going to do, I'll just come to cell. Now I'll just come to this side, the current output, and I'll just say clear to clear this to get it down for me. Or you can also remove it and just hit the enter button, and that will also give you something blank, right? So take note of that. Okay, so let's proceed. So we have done that to check the index. So now we can start doing the subsetting of the rows. All right, so let's proceed. So we are going to subset rows. So let's do this. So the rows, yeah, for now, let me just do this. I'll just indicate this first 5 here so that we just see some numbers here. That's fine. I can just say df, and then I'll proceed. So that's what we are going to do. For the rows, if you want to subset rows, we also have different approaches you can use. All right. So I will show you the approaches if you are subsetting based on rows. Okay. So we will start with the first one. So here we are subsetting a row and then all the columns. So if, let's say, you want, let's say, the first row, which is 0, the names are 0, then you can just say df.log, and then you say 0 like this. This one works. It will give you the row. So here you see the first row is this gen, and you also have x values here. Okay, p ISF value, p value, etc. So that is what has been indicated here. Of course, if you want the actual values too, why not? You can just do it. You can get it there as well. Right, so we have it this way. You can also do this. I made mention that for the log and the ilog, you specify rows and columns. Here I specified just the 0. So Pandas automatically tags it as the rows. I can also do comma and then bring this. It's the same thing you're also going to get. All right, so if it's for rows, if you are subsetting based on rows, then you can just, for the log, you can just use the row name like this, and then that'll be done for you. Okay, now let's look at the ilog function. I think I'll just do this. Let me just approach 1. Then let's say, let's go to approach 2. Let me just retype that. So approach 2. So approach 2, we use the ilog. So df.ilog. So ilog here, of course, is the same thing. We have 0, 1, 2, 3, yeah, that's order. So we can just use that here. So ilog 0, you can just do this, and then that also works fine. All right, so that's how we do it. Okay. Now you may be wondering why you have 0 for lock and then 0 for iLock. Okay. So the index names, they are numbers. Okay, so these numbers are also their names. Okay, so 0, the index is 0, 1 is 1 in that order. But then to appreciate it, what I would like us to do is to use the gene name as the index, and then we can appreciate what I'm talking about here. Okay, so let's do that, and then we can now look at the other stuffs. Okay, I think that will help us because some may be getting confused because it's the same entry. All right, so I will just change, and then we can do the additional queries or subset. Okay, so let's do this. Let's use the column name as the index. And so to do that, you just say df, all right, df.set index, and you specify the column name that you want to use. Of course, we have df.columns to give us the column names, and we want to use gene name as the index because we have each row has a unique gene name. So I'll just say gene name, right, and we have it like this. But if we do it this way too, if we just come back and type df, okay, it goes back to the original state, the original form. So what we want to do is to say df.set index gene name, comma, and we say in place equals true, so that it updates the data frame. So now if I say df, I'll see it's like this. Okay, I see it like this. So now we can now do the subsetting, okay, using the names. That will clear up a lot of things. So I'll start again. I'll say df.lock, and then this time I'll say what? Let's use the first one, which is wash7p, 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 like this. Now I'll bring this. So let's execute this command. Perfect. So now we see it's here. All right. So now if I come to iLock, df.iLock, and I still say wash7p, that's what I call it, wash7p. Now run it, I'm going to get an error. For the iLock, you can only use integers for it. So if you take a look at the row, let's say the indexes, this one has an index of 0. And so that is what we have to use here. This one here, the iLock, that's what we have to use here. And so what I'll do is to come here and then use the appropriate one, which is now 0. So this will give me something. All right. Now we've done it. These are examples of how to subset Pandas data frames based on rows. So now we can subset using multiple rows and then all columns. And so similar approach, we just apply our knowledge. You can say df. Okay, let me say df first to get the rows. Okay, or indices. So let's say df.lock. And because we are now going to use multiple rows, we have to put them in another list. So I have, let's say nd6, let's try this, comma, let's say cytb. I'm using these ones here, this and this, and comma, and I'll bring my column like this. I can even bring the dot values to get the values here. All right. Now let's try again. And this time we are going to remove this and just keep this. Then see, that will give us also something. Right. Now let's try with the iLock. So if it's iLock, df.iLock, This time use first and second like this, and then I'll execute it. So that will also give me something. You can also add a comma and then a colon, and that's also fine. That will also give you some outputs. So from here onwards, you will have to experiment based on what you've learned so far. You can experiment, make some changes, get some errors correct. This is how you learn and gain the experience when it comes to Python programming. All right, so that's how we do it. So now we are going to proceed. You will move on to this one. Let's scroll down. Yeah, let me just go back. Let's just make sure we have everything we need. Yeah, so what we've done so far was to subset rows but select all columns. That's what you've done. All right, so if you download the notebook, then you are going to find the steps also there. So that's what we've been doing so far with the current session. So take note of that. So now you can proceed. Let's scroll down. Yeah, to this section. So now we are here. We can subset both rows and columns. So that means instead of selecting either all rows or all columns, you can just select some of the rows and columns. So it's the same principle. So I'm going to just show a few of them. So for example, this one, it says select records from 2 rows and 2 columns. All right. So in that situation, let's say df and this. Let's say we are selecting this, and then let's say this. So we have to wash 7p, wash 9p. We can just say df. Okay. You can say df. Now this time you say df.log rather .log wash 7p, and then wash 9p or wash 9p. And then for columns, let's say gname. Yeah, here, yeah, it's good we do this. So let's say gname and then padg. Right. Let's try this and see. Now, if we do this, this is what's going to happen. Okay, it says gname. We can't find it there, right? This is because the gname, we had set it as an index, so it's no longer a column. It cannot be found. All right. So these are things you also have to be checking whenever you are performing some of these activities. And so what we are going to do is that I'm going to restart everything. That means I'm going to reload the data frame and then proceed. Okay, so we can either reload or we can choose to maintain and rather choose different columns. Let me just put it that way. So I can choose to reload and get everything as its default, or I can choose to maintain and then rather select different columns. Okay, so I plan to reload the data frame, but then I think you can maintain it and rather select different columns. Right, so padg, that one exists, so we can change the gene name to another column and then that should work for us. So I'll clear this again, and then I'll rather do this. I'll say df.log. I have wash7p, wash9p, and then when we come here, it's going to be padg, and then let's say p value. This one is going to work. So let's execute this command. Perfect. So now that has been done. All right. So this also means that if you are looking for information, I repeat, if you are looking for information, if you are doing a subset, then whatever information that you are given should exist in the data frame. If not, then you may encounter an error, or you may even get the output, but that may be wrong. You may be getting the wrong outputs. So you need to be careful. You need to pay attention to whatever you are feeding. I mean, there's a saying that garbage in, garbage out. So you need to make sure that you are supplying the right information, and then Python will also take care of the rest. Okay, so there's what subset records from 2 rows and then 2 columns. So we have that here. You can also assign the entire operation to a variable. And you can say subset equals, and then you can just say subset. So that will give you the result as well. And you can even save this to an output file. That's something you can also do. So that one, I'll leave it up to you. And I already have a tool that shows how to save a Pandas data frame to an output file. So you can just check the description box for that video. I repeat, you can check the description box for that video. In fact, that video is part of the introductory Pandas video I made earlier on. So just check that video, then go to that section. Okay, now let's proceed. Let's do this. Now we can subset records from 2 rows and then 3 columns. And so for that one, we can still use the same thing. I'll just do a copy and paste. And this time I'll add a 3rd column. So what column should we add? Let's say stats, S-T-A-T. Okay, you can do that here. So you can just add it here. So in this list, the column section, S-T-A-T, like this. Then you can run it. That will give you the answer. You can also use the iloc also to do the same thing. All right, so if I'm using the iloc, then it's going to be what df.iloc. Then you need to make sure you know the indexes. So if you take a look at this one, we know it, but this one, I'm not really sure of the number. Let's say 0, 1, 2, 3, 4. I think there's 4. So it's 0 and 4. So in a square bracket, you can say 0, 4. And when it comes to the columns, this, you can also check it here. Let's just check it here before. So df.columns. So this is 0, this is 1, 2, 3, this is 3. So when I come here, 0, 1, 3. So let's execute this command. So that will also give us what we want, right? So these are things you should always be looking out for. So there are different ways of doing the subset. So you can look at the one that was best for you and then use that. All right. So let's proceed. You can also get the first 5 records. You can also get the last 5 records. So here, first 5 records means first 5 rows and then all columns. And then last 5 records means last 5 rows and all columns. So let's start with the first 5 records. So you can use head. So you can say df.head. And you can get the first 5 records. So that means the first 5 rows and then all the columns. In R, it will have be head, and then you specify the data frame or table in the parentheses, but in Python, it's this way around. If you want more than 5, then you can just do df.head, n equals, let's say 6, let's say 7. That will give you your 7 records. Okay. The same applies to the last n records. So you can say df.tail. The default is 5, and if you want more than 5, it's df.tail n equals 7. So it's very, very simple and straightforward. All right, so that's how we do it. Okay. Now we were subsetting based on the rows and then the columns. We already knew the names and stuffs, but sometimes too, you'll be asking for information. You want to do queries, you want to ask questions, and you want to get answers. All right, so instead of specifying these things explicitly, you want to find out some information, you want to get some information. So you are asking and you want Pandas to give you some results. So that's the conditional queries. That's what you are going to do here. So this is also going to be very interesting. So I want you to pay attention here, and then let's have some fun. Okay. So before we do the conditional queries in Pandas Dataframes, I want us to reload the file. All right. So on the GitHub repo, let's get back here. So on the GitHub repo, the link to this page is in the description box. By the way, I repeat, the link to this repo is in the description box. So when we are here, come to this file, the seek_result.tsv. So click it. You'll be sent to this page, and when we are here, come to raw. We are going to load directly from GitHub. So I'll right click and then go to copy link to copy it, and I'll come and load it here. Right. So I'll just say df, or let me just define it again. I'll say data file, because I'll put everything in double quotes. So I'll paste it, I'll execute it, I'll make sure to print to see the link, and I'm going to load it. All right. But if you already have the file on your PC as well here, then you can also load it using the same approach that I showed earlier on. But I will load directly from GitHub, so that's fine. This file is a small file, so you can load it quickly from GitHub. So that's what I'm going to do. So I'll just say df equals bd.read csv. I'll specify a data file, comma, and I'll indicate a separator. So sep equals /t, everything in quotes, because we are dealing with a tsv file which has tabs as separators. So I'll execute this command to load the file. All right. So now we are going to do the queries. But of course, I'll start with just this one here, df, just to make sure I have some outputs, and I can start with the queries. So the queries is what we are going to do. We are going to select records where log2 change is less than 1. Okay, so I'm going to show 3 approaches, and then these 3 approaches, you can also apply them on the other queries as well. And where there are changes, I'll also let you know. So we are starting with this one. Select records where log2 change is less than 1. All right. Now let's say df.columns. Let's display the column first, and then we can proceed. Okay. So if I'm selecting records, let's look at approach 1. So approach 1, how do I do this? Let me just show it here. So approach 1, I'll say df, I'll bring my square brackets, and in it, I'll say df again. I'll specify the name log2 change. Then outside that square bracket, I'll say less than 1. We are looking for records where the log2 change is less than 1. So this is it. So you can execute it to get your hits. So you see them here. And you can also save this one output file. You can assign this to another variable, and then save it to an output file. But that's something I will leave to you. Or if you want to learn how to do that, just check the description box. The introductory video that I made on Pandas will help you do that. So that's for approach 1. For this one, let's look at approach 2. In approach 2, the same thing, because we are specifying the columns. It's just the same way we specify columns. So here you can say df, and then we bring our square bracket, and you can say df dot log2 change, right, less than 1. You can execute the command. So that will also give you the answer. So this is for approach 2. Now let's look at approach 3. In approach 3, we use what? df.query. You can say df, that's the data frame, dot query. Then you put everything in quotes. You can say log2 change less than 1. Then we can execute this command. So this will also give us the answer that we want. Okay. So just take note of that. So these are the 3 approaches. Now let's look at select records. Let me add the select records where the absolute log2 full change is greater than 1. Let me just edit and put it there. Yeah. So in the second task, you are going to select records where the absolute log2 full change is greater than 1. So here it's not just a log2 full change, but the absolute, right, is greater than 1. So if it's absolute, 1 will be 1, that's positive 1. Positive 1 will be positive 1, and the negative 1 will also be positive 1. So let's look at how to do that. So to do that, it's also very simple. Okay, so here I'll just try with one approach, but you can also try with the other approach as well. So let's just do it. So you can say df, bring a square bracket, and then in it you say apps. So apps here is used to find the absolute value. That's the Python keyword. So apps into brackets df dot log2 full change is greater than 1, like this. So let's execute this command, and that will give us our answer here. So you see all of them here. Okay, so it's so cool. You can try the other approaches as well. So for now, I want you to try and experiment with other approaches. So here, instead of df.log2 full change, you could have used the one in square brackets. Let's look at it. You can say apps into brackets, and you bring everything here. Okay, so app into brackets, this, and you specify a greater than 1. Okay, so this is also another approach to do it. Now let's proceed. So I'm just trying with one, but you can also try with other approaches. And if you also want some one-on-one tutorials on Python, you can always reach out to me. You can book a session, and we can have some one-on-one tutorials as well. All right, so just make sure to contact me. Okay, so let's proceed. So now I'll move on to this one also. We have select records where PISF value is less than 0.05 and then log2 full change is less than 1. So here we now have two conditions here, PISF value and then log2 full change. So I'll give two approaches here. I'll start with approach 1. So let's see how it goes. So approach 1, I'll just say, let me just type it here. Approach 1, I'll use df.query. So I'll say df.query PADJ is less than 0.05. And the end here is important because we have two conditions. And log2 full change is what? Less than 1. Let me do it here like this. So let's execute this command. So this will give us an answer. And again, you can assign to a variable. You can save this one output file. So that one, I'll leave that up to you. All right. So this is approach 1. Now let's look at approach 2. Approach 2, we'll do this. Approach 2, we say df. Okay, and then we bring our square bracket, and in the square bracket we specify the conditions. So we have condition 1 and condition 2. That's going to be the format. All right, now each of these conditions will also be in a bracket like this. Okay, so there's going to be, yeah, this end. Yeah, let me just do it here again. So this is how it's going to be. Now let me go over once again. I'll clear it. So for approach 2, you get your df, that's data frame, you indicate your square brackets, and then you have your two conditions. So we have condition 1 and condition 2. And then each of them will also have to be in a parenthesis like this. All right, so this is how it's going to be. All right, so now let's do it. And let me also say that aside the and, you can also use or and then not. All right, so it depends on what questions you are asking. And so currently I'm working on another tutorial where I show how to do queries. So in that tutorial, I will look at all the various scenarios, not just the end. Okay, this one is an intro to let you have a feel of the queries, and then later on we can go into details. So just take note of that. Equals to, not equals to, less than, greater than, all these things can be done. So we look at them in detail in another video. Okay, now let's come back to our query. So let's start. So condition 1 is what? Let's try it. Condition 1 is what? df dot what padj less than 0.05. So you see how it has been done. And say df dot log2 full change is less than 1. So these are the conditions. Now you can execute the command to get your answer here. So we have that also here. So that has been done nicely for you. All right. So this is it. Now let's look at this. You can also do each of these separately. That's a divide and conquer approach. You can split the problem into sub problems, get the solutions, and then combine them. All right. So for beginners, I think that would be very, very helpful. So I will add this. I'll just label it as approach 3. It's the same thing. So you will do this. We are looking for this. Select records where PISF value is less than 0.05, and then log2 full change is less than 1. So I'll do this. I'll say condition 1, and that will be equals to what? df dot padj is less than 0.05. All right, that's condition 1. Let me just put everything here. I think that would be better. There is condition 1, and then condition 2 is equals to df dot log2 for change is what? Less than 1. Let's confirm. All right, and now you can bring all of them to it. So you can say df, you bring your square brackets, and then in it you can just indicate your condition 1 and condition 2. All right, so you need to also make sure you have executed each of these. All right, you need to make sure you have executed each of them so that you have your results, and then you can finally execute this also to get your outputs like this. Okay, so this is how we do it. So if the query will be complicated, you can split them into smaller chunks and then solve them, and then finally merge all of them together like this. So this is even easy to understand, and for beginners it's very, very simple to understand and write compared to this one here, which can be complex for beginners. Okay, so sometimes you can just make things simple by splitting the problems into smaller subtasks and then solving them, and then finally aggregating your solutions together like this one here. Okay, so these are cool and interesting things. All right, so that's how we do it. Now let's look at this other query, which says select records where PISF value is less than 0.05 and absolute log2 full change is greater than 1. Now this one, I brought it here because when you perform your differential expression analysis, you may want to identify those genes that are significantly expressed. And one way to do it is to use some thresholds like this to subset them. So in some tutorials, you will see this kind of query where they say you should select all records or gens with PISF values less than 0.05 and absolute log 2 fold chain greater than 1. So that means you are going to identify gens that are up and then down regulated. So this is an example of how you can do the subset. So with this one too, because of beginners, we will just go by the simple approach where we split them into subtasks. So I'll start with this one here, condition 1. Okay, so I'll just say condition 1. You can even say condition PADJ equals, okay, and I'll say df.padj less than 0.05. That's the first condition. Then condition log 2 fold chain, let me say LFC. That was absolute value of df.log2 fold change greater than 1. And then you can finally combine it. So you can now say df, okay, where you have this condition PADJ and condition, let me just put it here, condition LFC like this. Now you can execute your command. So let's do that now. Perfect. So we have that also down here. Okay, so you can see it nicely done. Now, if you have already subsetted your problems, okay, then instead of putting your conditions in parentheses, you can do it this way. You can even say df. So we have condition PADJ and condition LFC. Like this. Let's just make sure I have the correct names. Okay, and then you can execute them. Okay, so you don't need to now put them in parentheses again, because what you are putting is the solution, the output, the result for those conditions. So you can do it this way, or you can also do it this way if, let's say, you are more cautious, you don't want any errors, so you don't want any risk. You can also do it this way to get the answer. Okay, now this is what we have. So if this is the gens that are significantly expressed, then you can also save them to an output file, right? So you can assign this whole operation. Let me just copy it. You can assign this whole operation to a variable. So you can say dgen like this equals, and you paste it there. You can execute it, and you can say dgen.shape to get the number of gens that are potentially expressed. So we have 1591, and you can even save it to an output file. Okay, so to save to an output file, you can say dgen.toCSV, and then you can specify the output file. So you can just give it a name. Let's say dgen.csv. I'll save it as a CSV file, but I can also save it as a TSV. That's fine. So if you want to save it as CSV, you do this, and you can say index equals false, because here the indexes are numbers and we don't want them. We just want just the records. You can save that. All right. Okay, so if you save it, then you can go and look up for it. Let me see. Mine is here. I've saved it here. There's it. So I can just open it to see what I have. Now, if let's say you are confused, you don't know where your files or where your output has been saved, you can just do it this way. Let me just go back to Pandas. You can just import OS, this Python model. You can say os.getcwd, your current working directory. Then when you execute it, it will show you a path. And so that path is where your output file has been saved. So you can go and then locate that and then get the file. Okay. So if let's say you want to save this as a TSV, then you can also say dgen.tsv to CSV. You give it a name. You can say .tsv, comma, index equals false, comma, sep equals /t. So when you execute it, it's saved. So you can go back here and then see it's there. Okay, so that has also been saved. So these are different formats, but the same information can be found in them. Okay, so it's very, very simple and straightforward. That's what we've done. Okay, and then you can do your other queries as well. So I repeat, you can, since this is a differential expression analysis, you can also visualize using some R and then Python packages to generate your volcano plots, generate your MA plots, etc. Of course, I'm tutorials on that as well. So just check the description where you find links to the videos that show how to visualize RNA-seq results. All right. So Python also makes it easy if you want to explore data by using the Pandas library, and that will help you to do lots of stuff. All right. So for those who also want to get a notebook, I repeat, the download link to this notebook is available. So download it, and then for those who also want to support this channel, there are links you can use to buy me a coffee. So I'll see you in the next video.